Hey guys, welcome back to my channel and I hope you are all doing extremely well. This is lecture 19 on my linked list series. So far I covered 18 lectures and I highly recommend you to please start watching from lecture 1 till whatever I'm going to post in this series. I strongly believe that at the end of this series you will be in a situation to crack any interview question on the linked list. Before going further, I request you to please subscribe to my channel and tap the bell icon to get the latest updates. Without further delay, let's get into today's lecture. In this video, we are going to solve one more leet code problem. The problem number is 203. The difficulty is easy. It's all about remove linked list elements. Let's try to understand the problem statement. We'll be given one list along with a value. The ultimate goal is we need to remove the node whose value matches with the given value. If we carefully observe this input, we have 1, 2, 6, 3, 4, 5, 6, and the input we are going to have the value as 6. So the ultimate goal is we need to remove the nodes whose value is 6. That is nothing but we need to remove these two highlighted nodes. After removing those two, we are going to get the output as 1, 2, 3, 4, 5. So that's all about the problem statement. Let's go to our diagram for a better understanding. And if my list is something this 1, 2, 6, 4, 3, 5, 6, 6 next is null. And if my value is 6, that means I need to remove these two nodes whose values are 6, this one and this one. And after that, my output is going to look like 1, 2, 4, 3, 5, and next. This is all about we need to do. Let's try to understand how we can solve this particular problem. If my list is this 1, 2, 6, 4, 3, 5, and 6, and its next is null, and my value is 6. What I'm going to do here is I'm going to have a pointer here, kernode. Okay. Every time what I'm going to check here is my kernode dot next is equals to 6. If it is 6, then I'm going to point my kernode is equals to kernode dot next is equals to kernode dot next dot next. Let me go through it. Is 2 equal to 6? No. Then I'm going to change my kernode to the 2. Is 2 snake 6 is equal to 6? Yes. Then what I'm going to do here is kernode dot next is equal to kernode dot next dot next. That means this is going to point to the 4. Okay. Then again I will check. Is my kernode dot next is equals to 6? No, my kernode still is here, okay, and my kernode next is now 4. Is 4 equals 6? No, then I'm going to change my kernode pointer to 4. Then again I will check, is my force next 3 is equal to 6? No, then I change my kernode pointer to I mean 3. Is my kernode next is 6? No, then I'm going to change its pointer. Is my kernode next is 6? Yes. Then what I'm going to do? I'm going to execute this one so that this is going to point to the null. So at the end you can return the head. If you return the head, your output is going to look like 1, 2, 4, 3, 5, and null because you are not connecting to 6 here and here also. And this is how you can solve this particular problem. So, I mean, this problem can be solved using recursion also, but we can discuss this when we go to the recursion topic. Okay, I will upload a video separately on this problem where I can solve this using the recursion also. But for now, you can learn about this iterative approach. What are the time and space complexities here? The time complexity is going to be big over n because we are going to iterate through the list only once, and the space complexity is going to be big of 1 because we are not taking any additional data structure or else any additional list to process the input. That's all for this explanation. Let me go back to the coding part. I'm here inside the editor. Let me have the base condition. If head is null, that means there are no nodes. Just return null, or else you can return head also. That's fine. Then I'm going to have a cur pointer who is initially points to the head. Then I'm going to have an iterator. The iteration is going to be while kernel.next not equal to null till this condition satisfies. Then every time what I'm going to do, if kernel.next.val is equal to val, that is we got it as a parameter here input. If this is the case, then what I'm going to do, kernel.next is equals to kernel.next.next. If this is not the case, then what I'm going to do, kernel is equals to kernel.next. That's all, only these two statements. And at the end, you check one thing because you are starting from the head. So head is going to be a value, right? Because like input set is something like this, 7 7 7 7. You are checking only these three. But what if your head also the same one? In this case, you need to return the null, right? So for that, just check if head dot val is equal to val. In this case, just return head dot next. That is going to be return your null. Otherwise, yeah, next. Otherwise, return head. That's all. Let's give a run. Yeah, it got run. Let's submit. Yeah, it got submitted. It took 1 milliseconds. That's all for this video, and I hope you learned something new today. Please do subscribe to my channel and tap the bell icon to get the latest notification from my end. Thanks a lot.